Good morning, everyone. Good morning and good afternoon. Welcome to today's session. We're going to dive into AWS Service Control Policies, or SCPs, and talk through 5 use cases, 5 tips from our cloud experts here, and 5 policies that we'll actually even give you at the very end to go use today. My name is Joseph. I'll be your host. It means I'll be answering all the questions today, keeping a monitor on the chat. I see everyone's already figured out how to use the chat and share where you're coming from. That's awesome. During this presentation, like I said, you'll see it on the side. There's a Q&A section as well. We'll do some polls throughout. And let's make sure the chat is working properly for everyone too. We actually came up with a card game a little bit earlier in the year. And one of those questions was, if you could describe your last audit with only a movie genre, what genre would it be? So drop that in the chat, what your last audit was. If it was a comedy, a horror film, whatever it may be, drop that in the chat while we're getting started here. Make sure everything's working and everyone knows how to find it. Pulp Fiction. James, Sandy, what's yours?
Oh, man, I don't know. Hopefully the last one was smooth sailing of some form. So I don't know, some very happy-go-lucky movie on that one.
Documentary. There you go. Awesome. Looks like people are in there. Thank you so much. And let's kick a quick poll off too. This is an AWS session, so I think I probably know the answer to this for most people, but drop a quick poll in there, and we're going to go ahead and see what cloud provider you would consider your primary cloud. It'll give us a little bit of insight. This is an AWS session, so if you don't pick AWS, I'll be shocked. But we certainly have a few polls dropping in now, and I'll go ahead and share that on screen for everyone too as we're filling out what everyone gets. You should see poll on the right side of your screen. AWS in the lead, good. It's an AWS session, all about SCPs. That's what I kind of would expect. Azure, number 2. GCP in 3rd. No Alibaba yet. Anyone else? Final votes here. All right. Azure. Thank you, Damien. Awesome. Okay, so we'll throw some polls up throughout. It helps our presenters even know what we're talking about today, how we're getting people in. Azure at number 1. Just beat AWS in the AWS session. I love that. We'll keep going today with more polls. And as a reminder, we're actually giving away a Nintendo Switch for the best question asked throughout the session. And you do have to be here at the end of the session for us to be selected. We'll pick it live on the session based on people that are here today and questions that are asked. Throw in relevant questions, stump our cloud experts. I look forward to them not being able to know the answer, and we'll go solve that after, but you would be surprising me as well if not. It is 2024, so yes, this webinar is being recorded, and we will make it available to everyone afterwards. With that being said, enough of me talking. We're going to pass it over to Sandy Bird, the CTO and co-founder here from Sunray Security, and James Berthodi. He's lived the life of a cloud security architect and now is the founder of Latio Tech as well. Sandy, over to you, sir.
Thank you, Joseph. James, welcome. Thanks for joining me today. This will be a great session. We've got all kinds of interesting content. We're going to dive into the weeds of service control policies in AWS. Looking at the poll, maybe we should have done an Azure policy instead, but we're going to do AWS. We'll have a further session on Azure policy sometime later. So James and I are going to take you through this. We have all kinds of interesting kind of examples as part of this, I will say, James. We've got stories from the field where, we've tripped over things and bad things have happened. We have great ways to describe how to use these. So it will be a fairly good session. Now, I am going to share my screen, and if this all works, James, I'm actually going to say slideshow mode here. I'm hoping that that's working. It looks like it is.
Yep.
So this is kind of our layout for the day. And again, thank you again, James. I just wanted to give James a shout out. He's done some real work in the field too. I think James previously at PagerDuty, ReliaQuest, and then again, your new gig at Latio Tech. I think James is going to be a great help as we go through all this stuff because he's just got great stories as we talk about it. So we'll cover a bit about what SCPs are. If you signed up for this webinar, most likely you know what an SCP is, a service control policy, and a bit about it. We're going to probably go a level or two deeper on that. We've got some interesting writing tips. There's some pretty interesting limits when it comes to SCPs in terms of what they can do, what they can't do, and where where you think they work, but they probably don't. So we'll do that. We then have some really interesting kind of scenarios, and we'll use some example policies and show you some of the language for that. Then we'll talk about some real world experiences. So we've got a pretty good agenda. As Joseph said, please keep your questions and throw them in the chat. You can do it anytime. You don't have to wait till the end or anything like that. Just throw your questions in the chat, and we will get to them as we go kind of through this. If something's relevant during a session, Joseph will interrupt us, and we'll talk through those as we go. So that's kind of the way we threw this. Now, James, we're going to turn it over to you quickly here for this kind of next slide, which is basically, what are SCPs? And so give us the rundown of why you might want to use these.
Yeah, I think part of what has made cloud security interesting and difficult, but very cool at the same time, is fundamentally every permission being an API, right? And Amazon specifically has released so many different ways that you can enforce permissions that honestly it gets a little complicated. And so that's why I like this graph here too of like session-based policies, permission boundaries, identity-based policies. So there are a lot of ways to enforce policies. And at the end of the day, we've all probably used that permissions analyzer thing that always like kind of half works from Amazon to get an idea of like, all right, well, at the end of the day, I've got this user trying to do this thing and I want to either allow or deny it. And it can be hard to sort through all of the different steps of if that allow or deny is ultimately allowed to happen. And SCPs are just like the be all end all final authority for an AWS account. And these are enforced at the organizational level and can be attached to OUs or accounts. But I think of it mostly at the account level. At the end of the day, I want to be able to deny a specific action that I know nothing should be happening, or if it's a conditional policy where like only this role should be allowed to do this thing. It is a very last line of defense. Like this is at least the boundary for what I want to not allow in this account. And so we talked a little bit as well. So with SCPs, you can set up deny policies, which is the main way that I've seen them enforce and use them to deny known bad permissions or known things that you're not using, you're not supposed to be using to avoid the sprawl that happens in cloud accounts. But it's worth mentioning you can also take an allow-based policy if you have some accounts that are like very specifically used for like IAM, and that's all the account is for. You might want to consider setting up like an allow policy that explicitly says only these permissions are allowed in this account. But in general, I have always used them to do very simple things like denying the huge list of services. The ones I always joke about are like AWS has like a satellite service and then their quantum computing service. Like you're probably not using those. So it's a good idea to turn those off. But there are many more nuanced examples. And then regions are the other common idea, just to get some use cases in your head for how you might deny these. And so that's really the way to think about them. It's an AWS provided feature, a super easy way to get a lot of cloud security so far has been around how do we set up least privileged access on a user by user basis. And this boundary approach is a much more realistic way to get like 60, 70, 80% of the way there, but just in the easiest way possible. And then you can tune that least privilege after the fact. So they're a very powerful, good tool for implementing account organization-wide permissions.
Yeah, thanks, James. I think you even use good examples. The satellite service is a perfect example. I know when we were testing when we were building the cloud permission firewall, which does a whole bunch of work with SCPs to build kind of these boundaries, that was always the one where like, how are we going to test this thing? It's not like we have any satellites to connect to, and I don't really think we want to rent any right now. So, how do we do this? So it's always a bit of a struggle for some of these services. They just don't apply to everybody. And, there's 300 plus of them. There's so many services. This is kind of interesting. We'll spend a little bit about time about how these work. And James had this great comment when he was talking, right? Mainly use these for deny, setting up this boundary, but they can be used for allows too. And I think this is where some people get confused. They definitely are a boundary, and they can only really ever take permissions away. They never actually grant permissions to any individual identity. If you want an identity to have the ability to, get an object or list buckets or something, they have to have some IAM policy attached somewhere to that identity or through a resource policy that allows them to do that. The SCPs, though, which are deployed in the org account, which is kind of an interesting thing in of itself since they're deployed in the org account, but they actually affect all of the other accounts in the organization. So you're deploying it in the org account, but you're affecting the production account or the development account that you build the workloads in. in every one of the points in that tree, the OUs that you build for your account structure and then the individual accounts, the SCP needs to have an allow that, think about that as the largest amount of permissions that are there. And AWS kind of bootstraps one in there called the full AWS access, and it's basically just star. But it's not actually granting anything star. You still have to have the individual permissions on the roles or the IAM users, whatever it is, so that they have those permissions. But it's the largest boundary, this kind of allow part. But because AWS has this great rule that says deny wins, the denies that go in the SCP actually strip away any of those permissions from that point and below in the tree structure. Now, this is one of these things where Amazon has all these weird rules and you have to learn the rules. The deny statements that you put at the top of the OU, or the deny statements that you put at a individual account, or I shouldn't say an individual account, say you put the deny statement at an OU level or down the tree at the next OU level, those propagate down the tree. So if you put it at the OU that contains an application, and underneath that you have a development account and a production account, whatever you attach there as a deny applies to both of the accounts below. However, the allow does not work that way. The allows have to be attached at each point that you want them to apply to. And that's why AWS has this kind of bootstrapped full AWS access attached to everything. However, you are allowed to detach it and create custom allow policies. Back to James's example, if you have a one account that only does IAM things, you could limit it so the fullest allow is just IAM star there, and you wouldn't even be able to run EC2 instances in it as an example. And so we use that a lot for denying services where the number of services that are being allowed are very small. Maybe you only want to allow 20 or 30, but you want to deny all the other 310. Hey, it's a better way to write the policy to basically create that as the largest boundary. They're written just like every other policy. They're JSON. They look like IAM policies. They have the kind of same structure. As you build these, you attach them at the right places, but the limits really get in the way. And if you start using these at scale, you run into limits pretty quick. There's only 5 attachment points at each point in that tree. So you can only really attach 5 per account. Now there's a way to game the system by using the structure. We'll talk about that in a minute. Each policy can only be 5,000 characters. So again, you end up with this point where as you're writing very verbose stuff and you're making it very human readable, you can run out of characters. And this is the really tricky thing. And AWS has gotten better at this in the last couple of years. They were really bad when they started. When you're in one of the member accounts and you bounce into one of these and you get denied, it's not always obvious from the account that you're in why you're being denied by this SCP. And you don't have access to see the SCPs, so it's really hard to debug. And so that's a bit of a thing when you're in here and doing troubleshooting for this stuff. You got to figure out. I always kind of use this kind of example. We've got kind of this example of like, why are they useful and why are they not useful? But I always like to tell these couple of stories. You know, James kind of talked about these permissions that you don't want anyone to have. Sometimes it's service related, but I always use this example that we used very early on here at Sunray Security was, if you know about AWS's billing, CloudTrail, you pay for any additional CloudTrails. You kind of get the first one for free, but then everyone you add after that point, you have to pay for. And most good organizations are going to set up an organization CloudTrail. So that's going to be in every account. But if a developer goes in and actually creates a CloudTrail for something they're doing to put the logs in, say, a bucket in that account or something, you end up being charged for that. And it can be quite expensive. And so we use this scenario where once the org trail was set up, we basically denied, the creation of new trails from that point any results. And that actually kept us at a scenario where we kind of knew we only ever had that one CloudTrail. It was a great kind of example. On the opposite side of that, though, we had this great experience coming out. I shouldn't call it great experience. We had this experience coming out of reInvent, which is the AWS security conference that just finished. And we were talking to somebody on the show floor that had built kind of an equivalent mechanism to the permissions firewall that Sunray Security sells, where they had built these kind of list of permissions that they wanted to deny everywhere. And they had built some interesting attribute-based access around that for controls. And they ran into this problem where they were getting denied and they couldn't figure out why. And they ended up literally rolling every single SCP they had out in order to get the application to run before they could start putting them back in. So anyway, lots of great stories for the goods and the bads of this stuff. Strengths, though, Centralized, you have centralized control. So now if you have a cloud ops team or a cloud security team, you really can create these guardrails that cannot be circumvented by the accounts and the developers and the accounts themselves. It's a great way to have central control. They really can be a backstop against things that you don't want to have be used. So you don't want the satellite service used. You don't want quantum computing used. You don't want any of the new AI services used. You can decide if that's good or bad for you, but you can use this as a backstop to have that happen. You can allow, so what's really interesting about this, the super sensitive permissions, create VPC or something that you don't want running everywhere and wanting everybody to use, you can actually use the SCPs to create these kind of like exemptions for certain roles. So your break glass accounts, your deployment roles, whatever, they can still do the things that you want them to do, create VPCs, change the security group rules, whatever it is, but stop it for everything else in your cloud. Every other identity will not be able to do it. So you can kind of get this ring fencing information. So its strengths are phenomenal and it's super powerful, super useful. The things you got to watch for on the weaknesses, and these are sometimes surprises to people. First of all, the organization account, probably the most sensitive account in your entire AWS infrastructure, is not protected by the SCPs where you're deploying them. And so you can put an SCP in that account that says, you can't change SCPs or you can't do these things. They just don't work there. They just don't apply to that account. So you need to understand that the controls are outside of that organization account on that side. The other thing that's a little tricky that's non-obvious is the fact that service-linked roles, generally speaking, get a pass. Even though you have SCPs that maybe stop certain permissions, if a service-linked role in an account has permission to do that, it will most likely still be able to do it. And so that's another thing that kind of is surprising from that. And then the last thing that you got to be aware of is that SCPs control your identities. So the roles that are in your accounts, in your organization, the IAM users in your account, and theoretically the resource policies in your account. If you go back to that little diagram James had, you'll see resource policies there. However, in resource policies and in trust relationships to things like roles, you can define the principles from outside of your organization. And because those identities are not in your organization, the SCPs actually do not apply to them. And so as an example, if you write, get bucket or, get object, S3 get object with a principal that's allowed to do it from some other AWS organization on that resource policy, that particular identity, which is outside your organization, will still be able to do it, even if you have an SCP that should block it. So again, those are things to you have to keep in mind. They're not the perfect silver bullet for everything. They have weaknesses on that side. So James, you've had some scary experiences over time, and you've been using these. Why can they feel scary, and how are some of the ways out of that?
Yeah, I think part of getting into security for me was to avoid the the crazy downtime feeling you would get in DevOps when like something's down and it's like on you to go fix it. Like nobody enjoys that feeling. And SCPs being like, you could break everything by making a change to an SCP. Like if it's a critical service that's allowed and you're suddenly starting to block it, like that's a position that nobody wants to be in. It creates a lot of friction with security. It can be frankly just scary to do. And so that's why I appreciate so much the idea of like just implement your first one to help you not get scared by it. And just pick some arbitrary service like that satellite one that no one's using and just deny it. That way, you're at least making this incremental movement towards it. Because fundamentally, that's the scary thing, is just getting started. But outside of just that piece of it, a lot of what you said about troubleshooting can be very difficult because you can't get to the logs easily, because it's not always clear what's happening when something's getting broken. It does require a little bit of training for whoever's going to be managing the SCP, typically the security team, but if it's other teams, like they need to understand like that's a place to go look when people especially start trying something new. But honestly, this has helped me in our past when Amazon releases a new service. It's usually because there's some buzz around whatever that service is. And so you will usually have developers, especially in like sandbox accounts, but even in staging environments, like rush to go and implement that new service right away. And so just having this basic controls in mind, make it so that at least you know, hey, someone's going to have to ask us to get access to these services before they're allowed to go implement them. And a second piece is that managing these SCPs, typically, or from what I've seen and where I've worked, organizational accounts don't have the same IAC pipelines and workflows that other downstream accounts have, because they're just not receiving these code changes all the time. They're usually just used for like IAM integrations and other things like that. And so that makes maintaining like the state of the SCP itself, to avoid all of the same reasons that people go to things like Terraform in the first place, where there's conflicts, where people can hit save at the same time if there's multiple people working on it. It's important to create some kind of idea of how you're going to handle workflows with that, whether it's something as simple as like a Slack thread to more complex, like implementing a branch of your Terraform or getting it integrated into the organization account. That piece can be really difficult. And so really, I think it's those two things where it's fundamentally the getting started can feel scary because you could break things with it. And then from there, the management can be weird because it doesn't fit into normal developer workflows. The final thing I'll say is the more complex your environment, right? This is one thing for me to say that SCPs are hard when you have like 5 to 10 accounts. But if you have hundreds or thousands of accounts, then you start getting into that OU inheritance thing. And you're starting to really have to think about, like, at first, it's easy to do these broad swaths. But over time, as you're thinking about what's the name of the Terraform role that we want to allow to take these actions, and like you're trying to stretch that across like an OU, for instance, like it can be difficult to consider. It sort of reminds me of like WAF rules when you start getting into these crazy like allow deny chains that can go on forever, and at the end of the day you don't know if something's going to get allowed or denied or not. It just requires a lot of thought down the road as you implement at an OU level. So really that's the reasons I have felt scared both implementing and making changes to SCPs.
No, I think you kind of hit the nail on the head there, James. It's, there's just so many things that could go wrong, and you don't want to hold up a workload that's really, really important. And then your examples on the organization account are super interesting because, we want automation for everything, of course. But the problem is that account is super sensitive. And then you're like, how much, what types of restrictions do I have around the automation? And all of a sudden you have this external entity that has access into this organization account. Is there any way that could be manipulated because it has, certain permissions? And so it is a scary thing to get into. I still believe, though, it is one of the most effective ways to get some form of centralized identity governance back into AWS, where generally speaking, identity runs wild a little bit in that scenario. We're actually going to go through some interesting stuff. So we're going to go through some tips for building SCPs to help people out and not have the scary experience. Joseph, who was on with us earlier, is going to throw a poll up in doing this that actually covers a bunch of these points, just to ask people in the audience which ones that they have run into. Hopefully these help people again as they're going through this. The reason a lot of these are here they're things that when Sunry was building the solution that we were building, they were things that we ran into and we had to build optimization around. The overall Sunry solution is very good at James's world of finding all those Terraform roles that run sensitive permissions and putting them in exempt lists so you don't have to know what they are. We do that for you, and we have a great way of getting the permissions back if you need them. But if you're just doing this yourself, there's some lessons learned that we learned that I think will be helpful for yourself, just writing those first set of SCPs if you haven't done that before. The first one that you'll discover, so go back to James's environment with the hundreds of accounts, you'll start to run out of SCP space fairly quickly because of the limit in the SCPs and the attachment limits. And so compressing the SCPs is a good way to do this. When you're uploading the policies, white space counts, so you can remove the white space. That's a great way to start to compress those. They become much less readable, though, I will say, when you remove the white space. The second thing that's interesting is that we have a tendency to write, as an example, I want to protect in this given service, maybe the create and the delete permissions. So I go and get a list of the create and the delete permissions, and there are 20 or 30 of those permissions for this given service that I want to create. And so I list all 20 or 30 of them, and it takes 20 lines to do that. And every one of them is probably 20 characters long by the time I get the service colon and the name of this thing. And I look across all that, and I discover that I really could have actually created the same SCP by using wildcards in there that says I want to protect create star and delete star. And so there's different things you can do for compression to try to make the statements as small as possible as you get into there when you do that. So again, lots of compression techniques really help. If you get familiar with doing that in the start, you'll be much better off at the end when you go to do that. Another thing that we did, yeah, go ahead.
Just for reference, our poll's open right now. Max number of SCPs in an org is the current most encountered issue, followed by max SCPs attached to root and attached per account.
Those are yep, very common ones. And we're going to talk about the 5 SCP limit attached at the org account here in a second, because I think that's a good way that we can help you get out of that. So, look, another thing that we did was, and this helps really with the maximum size of the SCPs that you're creating. James used this great example of you have some set of identities that you want to be exempt from these SCPs, right? The Terraform role that's rolling out infrastructure, whatever it happens to be. We can have lots of arguments if those things should be over permissioned or not, but the reality is often to make life not scary, and so you do not break things, you want those in there. But as your world grows, the number of exemptions that you have also grows with that. And if you're trying to put all of your SCPs at the top of the org, and you're making exemptions for all the patterns that every developer team has below that, you'll very quickly run out of exemptions. And the reason that is, and we'll show some examples of real SCPs as we get further, but you'll see where you're probably putting scenarios in it where you're using not resource, or where the principal ARN is not matching the string or whatever it is. And if you do that enough, what happens is you just run out of SCP space because the JSON gets so big. Amazon has this really interesting thing called attribute-based access control, ABAC, which allows you to use attributes of the things in the clouds, things like tags. Tags is the simplest one to explain, that will allow or disallow access in IAM policy. And basically, by using that, you can create some of those exemptions in scale using the cloud resources themselves, like the roles as an example, versus having to write all of the exceptions into the actual SCP itself. And so you can get a lot of kind of compression in doing that using something like ABAC control. This is the 5 limit one, which I think a lot of people in the poll are saying is problematic. And especially if you don't use all the space. So think about it. You have that 5K worth of space that you could write in your SCP, but you do one to protect E2, and then you do a different one to create protect IAM, and then you do a different one, which is things I don't want my developers to do or whatever. And you've got these 3 or 4 policies, and you want to attach them all at a point. Well, you run out of space pretty quickly because you only have 5 attachment points. And the 5 is kind of a facade in that you really only have 4. And the reason you only have 4 is if you remember back to our example of the AWS full access being attached at every point, it's using one of your 5 spaces. So to kind of get past this 5 SCP limit, there's a couple of things you can do. One is clearly use up the 5K of space in each of those SCPs. That's the first thing you can do. The second thing is start pushing your SCP attachments down the tree. And if you know that you only have, let's say you have 3 levels, you have root, you've got a bunch of OUs underneath of it, and under those a bunch of accounts, you can actually have 5 levels of depth. So you can inject new OUs just for the purpose of attaching SCPs to above the OUs you currently have. And you're going to go into the Amazon interface and you're going to discover you can't do that. There's no way to move OUs around. That's okay. Very easily, you can script this by injecting an OU, reproducing the same structure you have underneath of it, and then just moving the accounts from the current OUs where they are to the new nested one that you just created. And as long as you're careful in the policies and things that you have attached, you can do that quite seamlessly as you go through that. And so through that, you can get these extra layers of OUs to attach more things to. So again, up to 5 layers of depth there. So if you're not using all 5, create some fake levels there at the top for getting those extra attachment points. And so you really kind of can start to hack that. The fifth one, I'm actually going to talk about more on point 5, because it actually gets into what you can use that full access thing for. But you can also do some interesting stuff using that full access policy for your own purpose versus Amazon's just default attaching there. James, you had some comments, I believe, about some of these as well, including this kind of balance of efficiency and customization, and some points. Any comments you want to throw in here as I kind of go through these?
Yeah, I think this is probably the core issue with AWS IAM in general, as far as like what roles do we make for people? And because our temptation as security people is always to make them as narrow as possible, because that's what we should do, like it's least privilege. But it just doesn't match the reality. And I think this fits in with even like when you think about designing permissions in a product, like when you go in, you get a role assigned to you, like a developer role or a security role or an admin role. And there are these much vaguer boxes of things. And I think that can help even in the context. I was thinking about this with the SCP org limit, where we, even if it didn't necessarily make sense for these 4 different like bundles of denies to be in the same policy, it would have made more sense for them to be separate policies, but we put them all in the same deny, just with different IDs on them to make it still readable and thing, just to get it all into a same policy for us to apply. And so it's the balance between keeping things general, so you don't end up having to apply all these specific policies, while bundling services together. And I think some of the examples that we bring up are a good idea of, even if you use all of the SCP examples, there's no reason that they have to be in like separate policies. Even like you really can consolidate all of them into a single one, to save on the space.
And I think you're right on. I think, and this is the scenario you had mentioned, as an example, trying to build automation in this and possibly even, whatever, put them in GitHub and create a PR process around them or something. You may want to store the snippets separately because they're easier to read that way, right? But then you may want to build an automation process where you could, bundle them up into, you hit 5K. So, it's pretty easy to write code that can count the characters and figure out what that is. It could also strip the white space out of it. It could also, so you can do this kind of scenario to say, look, let's store the rules in a highly readable format somewhere, and then use something to basically automate putting those things together as these more kind of compressed and efficient SCPs, but have a spot a human can go and look at them and understand what they do. I think that's a good approach too. We see that in a lot of our financial customers. They typically will do things like that. They'll have them checked into a repo somewhere. They'll kind of have the human readable versions there. And then they have some piece of automation that actually does this kind of compression and then deployment phase as they go through it. So we probably should have called this point, the efficiency, customization, and readability, because it's they get pretty hard to read if you get them kind of bunched up. So, and then finally, what do we do with this AWS full access thing that's kind of stuck in the way? You've hit your 4 attachment limit. You really need a 5th one. And you can't take this AWS full access one out because as soon as you do, it breaks everything. It's a good note. Don't take this one away and not put anything back in its place, because it will break anything. You have to have this kind of allow in there that's the outer boundary. This is where you actually can gain space back really quickly. So this policy has almost no characters in it. It basically just says allow star, and that's it. So it's, it's used hardly any characters out of its limit. And if you remember back to what James was saying about, there's certain services we want to allow, but a lot that we want to probably deny. There's a way to actually use this policy to your advantage and gain space back. And so what you can do is that, and remember, this is an account by account basis. So you've got to attach it at those points. But what you can do is you can write, and this is where AW gets really tricky. You can get into the negative conditions and things. And so you can use things like not action. By the way, super dangerous using that in IAM policy and other reasons, but in SCPs, it's actually hugely powerful. You can use not action to kind of invert the logic. So you can say allow, so I want to allow these, but not action the ones I want to allow. And so what happens is you end up with a smaller list of 20 or 30 things in your allow, but those are the only ones that are allowed. And when a brand new AWS service shows up, you didn't need to know what it was to have it denied. And so there's this really interesting use of this AWS full access to gain space back in your SCPs. So turning it into a custom policy instead is often a better way. So anyway, some good stuff there. James, you're going to take us through some use cases. I've got some comments on them. You've got some comments on them back and forth as we were going to go. I know you're going to talk about some stories as well. I'm going to hand it back over to you for a minute or two as we go through this.
Yeah, I think this is probably where I'm the most grateful for webinars like this, and even like Sunrise focus on it, is the limit too often on these SCPs is like our individual creativity at like, oh, what if we did this, or what if we did that? So I think just bucketing these into some areas is super helpful for just knowing like ideas of what to do. So like controlling regions, I'll just start with that one because that is a very low-hanging fruit for most people. Are not using every single region that exists in AWS. It's a simple way to, you don't want developers spinning up EC2 instances in EMEA. Like that's easy to turn off via SCP. Best practices, things get a little trickier because best practices are always debatable. That's why like CSPM as a tool category is so tough to figure out, because one person might think that a finding is critical, but another company might think that it's like, why would I ever care to see this? So this is really just most companies have decided how they want their infrastructure to get deployed. And that's a mess and different accounts and things. But at the end of the day, if you can limit it to just a few roles or a few accounts that have the ability to do some of these big actions, that's really what I think of as the best practices is, everything in this account should be deployed via Terraform. So here's our Terraform role, and just kind of limiting things that way. Blocking identities from disabling controls. These are the kind of AWS permission stuff that you wouldn't necessarily think about natively. So I like some of the example policies around this of things like turning off guard duty, like turning off CloudTrail, the kind of stuff that just doesn't come to mind because you're thinking like, oh, I'm seeing all of our CloudTrail logs. We would detect an attacker. But if the first thing a smart attacker does is turn off CloudTrail, then you can't see anything anymore. And so it's a good way to actually, part of the threat detection protection is using SCPs to make sure you still have visibility no matter what, should someone get into an account, take over an identity, anything like that. Same with encryption rules. Like a common, one of the most common CSPM alerts I saw in my career is like, oh, this isn't encrypted, or oh, the developer forgot to set encrypted equals true, or this like frick, now we got to go through and like clone the drive and copy the data over and encrypt it. And it's like, it's so hard to fix encryption after the fact, that whatever you can do, IAC stuff is great, but it requires that people use IAC. And so enforcing encryption at an SCP level is a good way to just force developers to have those conversations with the security team around like, oh, why am I getting blocked? Well, it's because we need to be encrypting this and you forgot to set the encryption standard. And then finally, the perimeter breaches. I think this is the most interesting aspect of SCPs and about this boundary approach in general that's beginning to catch on. And AWS, Amazon's also like writing about this more themselves about if we know where permission should be coming from, or we know where certain accounts should be taking action, we can really go a long way to preventing most identity-based attacks in general. And so it's a great low-hanging fruit way to do a lot of like attack prevention in the first place, beyond trying to worry about every specific least privilege policy. And so overall, I think these use cases just get at the idea that you can get a lot of security payoff with just a few smart rules. And it's really just about thinking about those is the hard part.
I think you're exactly right. And it's, we've seen so many examples where, whether there was an attack or even a red team exercise, and somebody is able to manipulate some of these dormant permissions that are sitting there for, a nefarious purpose. If it's an attacker, it might really be nefarious. If it's the red team, it's the way that they pop the account and get to, come to the team and say, this is how you screwed up. But we just see so many patterns where the thing that they do was a sensitive permission that was never used by that identity before, right? And I always use the example of the thing that goes through the Git runner and then creates an IAM user. That thing has never created an IAM user in its life, but it had star permissions because it was the Git runner and somebody thought that that's what it should have. And so that should have been one of those things that was kind of protected by default. And James, I was gonna hand it back to you anyway, and because you had a few more kind of points on this slide too that I think that are interesting.
Yeah, real quick, I thought you might know the answer to Adrian's question that just came in here about testing SCPs. Do SCP results show up in the policy analyzer or the simulator?
So they have recently, and I was talking at Reinforce this year. I was talking to one of the AWS consultants that do a lot of work. And they've recently added the feature for the IAM access. It's IAM access handler, but now it's running in the organization account. And so it will do things to test SCPs, but it doesn't always do exactly what you want it to, I would say. It's almost better at detecting overlapping SCPs and things than it is about testing you if it's going to break something or not. So, there's still limits in some of the AWS tooling for how SCPs work. The other thing, this is another great example from Reinforce. We had one of the 10 largest companies in the world. One of the engineers came by that was responsible for their SCPs, was quite curious about what we were doing and some of the stuff. And we just had this great session where we were talking about all the pain in trying to build automated SCPs around analytics, because every AWS service has slightly different error messages for when you trip over an SCP. They don't all say explicitly denied by service control policy. Sometimes they just say explicitly denied. Sometimes they say other things. And so you run into these. So yes, there's some good stuff that IAM Access Analyzer has added in and around the analysis of SCPs, but it's not 100% complete yet in terms of everything that they want to do when they get there.
And then Adrian followed up about, I think, meaning more about testing before you do a deployment. I've always done it with test accounts or sandbox accounts, but is there something else that you've seen be effective?
We, again, completely agree on the test accounts. That's a great way to do it. We have started to recommend this, but it's, again, we're not here completely to sell solutions, but I'll explain what we do and why we do it, and then you can figure out how you can implement it on your own. So when you use the cloud permissions firewall for summary, think about it. It's putting an SCP in that denies a bunch of actions and permissions. So think about create user, create IAM, or create VPC, whatever. So they're denied by default. And when the developers go to build the application for the first time, they bump into those. And so we have hooks written in the cloud that say, hey, the developer just bumped into, they were building Terraform, they bumped into create VPC and they were denied it, and then somebody has to approve it. What that's doing is in that test account, it's basically building, when this piece of Terraform runs, these are the sensitive permissions it's going to need. So even though I've deployed it with a star permission, it doesn't actually have star because most of the stuff is controlled in SCPs. And then basically we give the permissions back. But as you know, in AWS, when you move that from the test account, the dev account, into the production account, the identities are now different. So the exemptions you made in dev don't apply in prod because the ARNs have different account numbers, right? And so what we do instead is you can kind of lift that as a manifest to say, hey, here are the exemptions that are going to be needed in prod when it goes there. So you could implement something very similar to that, where you're testing the SCPs as you're building out the workload. You're keeping track of the ones that it bumps into, and however you're doing your exemptions, whether you're using ABAC or you're actually writing them as exemptions in SCPs or whatever it is, you do that work, and then you just lift that as the manifest file, and you basically just have to change the account number in the ARNs. And that works quite well too for doing that. But you have to, it's the day one problem that you have. I have a running workload in prod today. What does it do? And that requires you to go through the logs and all those things to figure out what the current set of sensitive permissions it uses are.
Well, I don't want to go too far down this rabbit trail, but what you just described is so fascinating because it's applying just-in-time permissioning via a boundary approach. And so it's a very interesting combination of those functionalities.
It is. We would have never thought that you would want to use just-in-time provisioning for things like workload identities. But actually, as we built this product, it was It's actually one of the most common use cases is actually what people want to do, because when they get red teamed, it's not the human identities that get popped. It's usually the machine identities, right? So anyway, lots of good stuff there.
That's very cool. So to talk about some ways that I've used SCPs, honestly, it's been like the very basic stuff that we've talked about, like denying unapproved services, forcing sensitive changes to come through Terraform. Like that's definitely the main one, is just having, here is our AWS role that should be the one making all of the changes. And so we can just allow that. And typically the Wild West of sandbox accounts is interesting because sandbox accounts have like a nasty habit of turning into production accounts over time. And SCPs are a good way to sort of limit how Wild West they can get, as far as making sure people, like trying to limit like elastic IP assignments and things like that, even to make it so it's a little bit more involved to try to set up a new publicly facing instance than it might seem. So a good way to enforce like network controls around those access as well. But as far as like why I've used them beyond just the how, usually the adoption of an SCP has been because we're forced to realize that as good as our IAM implementations are in production, there's no reason to frankly not just deny stuff that we know should never get used. And so it really is like just a low-hanging fruit way to enforce this across our entire organization. And every security team, especially when you start getting into like acquisition territory, like that's always where things get real crazy, where how long is it going to take before you get the level of visibility into an acquisition that you had into your own environment. SCPs are great. Like if you're adopting the accounts into your org, they're a great way to help, like just at least know that you have some amount of security around those accounts before you start deep diving into like what's actually there. So it's a good way to force processes to be followed, to get basic visibility into some different accounts, and really to create that that baseline approach of what you want to allow or deny in your cloud. And so the pros and cons of doing it, like the pros, like everything in AWS, when you set up your first one, it's nothing but pros. And the cons tend to come down the road when you've got this like giant, crazy, complex nightmare of policies. And then you're trying to compress them and you're trying to fit them together and you're trying to map out the permissions using like the logic of deny or allow across the accounts. So it's all about having a clear strategy of how you're going to get from just recognizing that the complexity is going to come, I think is what's important. And even though you're starting simple, just keeping a vision in mind of like how complicated this can get and sort of trying to plan ahead of time for how you're going to deal with that so that it's not this giant surprise only once it's too late. And then all of a sudden you're contracting people and they're coming in to try to fix it and what's going on. Like that's the position you don't want to be in. So it's more about just that planning up front.
Definitely. Yeah, I love your last point there. Organization accounts are weird. They have different rules and everything else. And they're also the one that you have to keep everybody out of all the time. So it's, again, we could have a whole nother webinar on what to do with your organization account and the rules around it. Look, James and I have created these kind of 5 examples. There's a great blog post with Joseph will drop in the channel that has some more details. There's I think there's a GitHub repo or something where you can copy and paste these. However, this really is a precursor to a month from now. We're doing an actual workshop where we're writing SCPs live, and we'll do examples that people ask and things like that, which will be a lot of fun. But we'll go through these examples, and James, hopefully we do these in the right order. I think this one's mine and yours is the next one. So we're going to try them in this order. But we know them all anyway. So one of the things that I love and hate about all these cloud providers are they have these interesting functions that take resources and make them public on the internet, bypassing every network control you've ever had. And there's examples of these for things like the URL to trigger a Lambda function, or the notebook URL for a SageMaker notebook, and the list goes on. There's all kinds of these. And it's very rare, especially in a sandbox account, that you want these things to happen. And maybe in very specific workloads you do, but it's certainly rare that you don't want things in your sandbox just randomly showing up on the internet. And so SCPs are a great way to do this. And so if you look across all the AWS permissions, and I just search for something like URL in the permission name, you're going to get a lot, but not that many. You'll start to see these things like create function URL config, whichever. And using conditions. So the way that this one works, if you look at the Lambda one, it's using a condition statement, not equals. And so again, we're using a negative syntax here, right? We're denying, double negative, deny, and then negative again. But what it's saying is that the auth type has to be IAM. So even though it says string not equals, when you apply to the deny and you get the double deny, that basically means it has to be an IAM authentication mechanism, not a standard just triggering the URL directly. So anyway, a good SCP for that, I would actually add way more permissions than these 3 examples. That's the SageMaker one, I believe, up there, and then the 2 Lambda ones, but there's more that you could put in. We'll probably cover those in the workshop. But it shows you an example of a syntax where you can just deny the permission outright, like the SageMaker one, nothing. Or in the case of the Lambda one, you may want it to actually work with IAM-based authentication. So you can use this kind of double negative with the deny and the string not equals to get to a point where it only allows the IAM type of authentication. So anyway, that's a good one. James, I'm going to hand the next one to you. This is, I think you kind of already talked about this, but the making sure you can't tamper with the security controls that you put in place already.
Yep. And that's, I know we want to leave time for Q&A as well. So I'll just go pretty quick on this. Like, attackers will get in and try to do this stuff if they're sophisticated enough to care about detection. Like, this is the common ways they would get detected. So yeah, and it's the kind, like, the only thing it potentially messes up is developers who like accidentally make a CloudTrail and then they can't delete it after, which hopefully they would tell you. So it's a very low risk sort of policy to implement.
Yeah. And again, there's more of these, if you're using AWS config, you're going to have some config ones in here. The list will be longer than this, but this shows how to do it. It's very easy to do. And if you ever need to do it, you make an exemption in this org account, you go in, remove it, do the thing you need to do, and then turn it back on afterwards. Security best practices. So we get mad at Amazon sometimes for things like public buckets and the fact that you can still create IAM users, even though we shouldn't be using them anymore and all these things. But let's say you got your cloud to a good state, right? And you've removed all the default subnets and you've removed all the IAM users and you removed all the access keys and you don't want them to ever come back. This is a great way to just say, hey, we've fixed this. Let's not allow somebody to turn off the control that we've put in place and put the default subnet back or create a new IAM user at this point. Once you've cleaned them up, let's leave them out of there, right? And so these are good examples of doing that. And there's a bunch of like account control policies for like public S3 blocks and EBS encryption and things like that. If you've got those things turned on in the good state, you don't want people to be able to run the commands to turn them off in the bad state. So here's a great example of those ones. James, back to your encryption.
Yep. And this is only for S3 buckets, but it is one thing to tell people to turn on encryption, but it is another thing to enforce it. And so that this gets it. Now, I think with these last two or even these last 3, we're in sort of like, you got to think about it territory instead of like the easy just auto apply. So for this, like, you want to make sure that you're at least scoping this to buckets that are encrypted or need to be encrypted. But it also, what's interesting is this last example, the AWS KMS DSSE type of encryption is like a brand new kind of encryption from AWS. And so it gets at with these policies how if you're starting your program with a almost fully like breaking the barrier SCP, you're going to run into the issue of needing to tweak it for new services.
Yeah.
So.
New services, new function, both.
Yep.
Yeah. So I do like, again, there's ways to write these SCPs that have these kind of or scenarios, right? This or this or this. And so you can kind of get all your examples in there. And again, separation of duties, my favorite. Can spend way too much time in my life in the IAM world, right? But there are certain things that you don't want everybody to be able to do. You have a certain process for, as an example, putting in identities and attaching policies to them. Make an exemption for in this case, the my IAM assigning role. And it is the only thing that will be able to actually use those services and apply those permissions. And so you can really create a nice separation of duties. hardly ever see this in anyone's cloud across, as many examples as we see. It's very rare to see people at the maturity level that they've actually gone and created a true separation of duties around IAM, but you can certainly use SCPs for that. James, you were right. James told me before this we were going to run long over. I said, James will be done in 30 minutes. And James clearly won in terms of the time. I'm going to stop sharing. We're going to try to answer some questions here. If there are some, Joseph, we're going to try to give away a Nintendo Switch, and we'll go from there.
Yeah, we'll do rapid fire Q&A. First and foremost, you kind of already answered this. Actually, you did already answer this, but how do you test SCPs? That was a great question. Just a reminder that was already asked. Answered. Edgar asked, we need to temporarily lift SCP restrictions for a major migration. Can we apply time limiting exemptions to SCPs that will not stay indefensible?
You can actually. So if you're familiar with the IAM and condition policies, you can put time barriers and stuff in there. I probably wouldn't do it that way. I would just have a scenario where literally we know we're going to take this SCP out for 5 hours during this deploy window, and then we are going to put it back, and I would just do it again at the 5 hours. I don't think I would try to write crazy condition statements to do that based on time. You're just kind of wasting SCP space, honestly. So I don't know.
It reminds me of the fun AWS game you can play where it's like, but what if you created a glue job that ingested when the change was happening and then set it up to an SQS queue, and that altered the policy to increase the time as the change was happening? Like, yeah, the potential complexity is always available to you.
This next question from Adrian, what's the minimum number of policies per OU? Sandy, I think you had a slide on that.
There's no minimum number of policies. There's one. So the minimum is one. You have to have something that allows something. But there's no minimum number that's the problem. It's the maximum side that's the problem. The 5, you run into the 5 limit pretty quickly, actually, especially if you're writing small snippets and putting them in separate policies.
Edgar asked, what methods would you recommend for utilizing SCPs to enforce specific parameters in Amazon ECS task definitions?
What methods would you use to recommend utilizing SCPs to enforce specific? You'd have to, James, love yours on this one. You would have to go through the CloudTrail data to figure out what is already in use, because you're trying to, again, and SCPs are denies, remember, so you're trying to remove the ones you don't want. So you'd have to find out the ones that you are using in order to write the negative rule to say, and not these ones, I believe. I have to admit, I have not written ECS task definitions in IAM condition statements recently. So,
James, anything you want to add there?
Nope, I agree. ECS is weird and hard.
Great stump question, Edgar.
This should be one for the workshop next month. Let's put this one on the list, actually, Edgar.
We'll prep this for next month. Yeah, next month it is. Good question, though, Edgar. Thank you for that. And actually, you know what? We'll put you on with Sandy. You guys can stump and figure that one out together after. That's a product question here. This one, GCP has organizational policy services. If we're multi-cloud, how does Sunry help us maintain consistent policies across AWS, SCPs, and GCP org policies? Sandy.
So first of all, GCP and AWS luckily are close to the same in that deny wins. Azure is not that way, by the way. Azure is allow wins. But because AWS and GCP are close, you can actually build kind of a set of commonality against this. However, the way it's implemented in GCP is completely different. And so again, Sunry can help you normalize it, because we can say, hey, you want to protect the services that are the data services, and we can write GCP deny bindings just like we can write SCP ones. If you were doing it yourself, you would have to have some mapping between service types and permission types and categorizations and things. But I used to think that all clouds had to be the same and we needed to normalize everything. I am less certain of that these days. There are so many unique things about each cloud that sometimes unique wins. So
I think I'm seeing more and more multi-cloud adoption stuff for this purpose. And it's honestly kind of scary from a security perspective. Like, it was so easy to stay out of like Azure and GCP. But now if it's like, man, that Azure Gen AI service is looking real juicy, and like the GCP Kubernetes stuff is like getting a lot nicer. So things are definitely getting scarier for that.
Yeah. And it's
well, I know we're at the
we are.
Sorry, Sandy. I know we're at the top, and I want to make sure we pick our Nintendo Switch winner. So thanks, everyone, for your time today and joining. Two final things. Like Sandy said, we are hosting a session next month where we're actually going to work through writing these policies with you live. If you want us to just send you an invite, you don't have to register. In the poll, you can select yes, and our team will make sure to send that to you. We'll follow up the recording shortly. If you want a certificate for CPEs, keep an eye out for an email from our team. We'll send you guys a PDF for that. And ironically, we just taught you how to write SCPs. But if you're looking to never write an SCP again, Center Security can actually help you with that as well, specifically for the use cases that we just talked about. And we're actually going to extend, we normally do a 14-day trial, but we'll actually extend that to slightly longer. We'll do a 30-day trial if you're interested in giving that a shot in the next couple days. So with that being said, James and Sandy, favorite question from the session?
James is my guest. So if James has one of the questions that he loves, then, and I agree, then James can, which one do you think, James, out of the questions that were there?
I feel like we got to do the ECS one because it was what stumped us.
I kind of agree, actually. I'm saying if that was the one that we couldn't, rattle off the exact condition statements that you would put in, then I think that one wins. So.
All right, Edgar, you won, sir. Keep an eye out for an email from our team. You'll get an email from a gentleman named Matt Shelton. Just a reminder, again, 30-day free trial. If you sign up today, we'll extend it so you have a whole month to go play with and block all sorts of services, unused permissions in one click. So click that button there in the chat. And thank you again, James and Sandy, for joining us today. Thanks, everyone, for joining live. Congratulations, Edgar.
All right.
Thank you.
Thanks, y'all.
Thanks, James. See ya.